So I hope you guys able to see my blackboard, right?
Yes.
Okay, and I'm gonna use the blackboard in the class. Okay, because I not use PPT because from PPT normally people will just read the stuff from PPT. Okay, so I gonna draw and all those things in the blackboard. Okay, guys. So now it's time to do both side conversation. Okay. So as we know that we are here for VXLAN today. Okay, we're gonna discuss about VXLAN. So I need to just may need to understand how much you at least basic knowledge of VXLAN. Okay, so why this VXLAN come into the picture? What is VXLAN first of all, and why it comes in the picture, and where you gonna use it? So can anyone of you tell me?
So overcome layer to
Can you little bit?
have to overcome layer to limitations.
Mm-hmm. So what is VXLAN, guys?
Virtual LAN.
Mm-hmm. So virtual LAN is VLAN.
Layer to overlay uh, over IP network.
So layer two.
Overlay over an IP network.
Okay, so layer two overlay over IP network. So it can only be the layer two overlay, or it can be layer three overlay as well. So sorry.
Layer 2 and layer 3.
Mm-hmm. Okay. Some people are writing extension of layer 2 to multi DC environment. Okay, so multi DC environment, which means between data center, that is okay. But if I want to go within data center, so can I use VXLAN if I don't want to go outside of my data center?
to eliminate the use of spanning tree.
Mm-hmm. Oh, that's okay. Okay. So let's understand first, because again, nowadays IT companies, lot of buzz is there for VXLAN, right? Everyone wants to know what is VXLAN, or even guys, you need to understand it, right? You need to completely understand it. But first of all, to understand any technology, that's a good thing. To learn any technology is a good thing. But first of all, you need to understand why that comes into the picture and what are the use cases or benefits of it. Okay, because at the end of the day, if you are doing the network engineer or administrator operation job, then that's okay. You can just troubleshoot the things and all that stuff. But if you are at the architect level, okay, or if you want to grow up to architect level, then you need to understand different protocols with the uses of them. Okay. So VXLAN comes. So before getting the VXLAN, let's understand some of the problems you will have in data center. Okay. So how is the architecture you will have in the data center? First of all, you will have two different type of architecture. One is three-tier architecture, which consists of core layer, distribution layer, and access layer, right? So here what is going to happen is either you will have a layer 3, layer 2 boundary at your distribution layer, or it can be over the core layer as well. Okay. So this is, you will have three-tier architecture. Now, some of the data centers you will find two-tier architecture. Okay, where you are having spine layer and leaf layer. Okay, so spine is gonna be, if you compare it with your three-tier, it is gonna be like your core layer or distribution combined into that, and leaf is gonna be your access layer. Okay, now again, it depends how where you want to demarc. Either you can demarc it here, okay, or you can demarc it on the access layer. So my first question to you guys is, if we talk about data centers, do you find any benefit of using two-tier as compared of three-tiers architecture?
Less complexity.
What else? Something related to bandwidth? Any difference happens in bandwidth point of view? So three-tier architectures are usually having oversubscription ratios. What do you understand by oversubscription ratios?
Ten is to one.
So again, it depends, whatever is the ratio. But again, for example, in middle, you are having 10 gig links, right? And this is a 40 gig link. And you have a lot of 10 gigs links. For example, 10 links of 10 gig. So total is gonna be 100 gig, right? And over the top of it, you are having 40 gig. So if every server is sending this at a 10 gig speed, and over top of it, you are having it 40 gig, okay, over one link, right? Although symmetric links you can form with symmetric speed, but that will cost you more, right? So here what you can do is, on two tiers, you will have no oversubscription on the egress point, okay, because your devices is gonna be connected directly with your leaves, okay, means your spines, which is at level 2, is gonna be connected directly to your leaves. So you don't have much oversubscription, okay, on the egress side. Ingress still you will have it. For example, if you are having the servers like this connected, which is 48 of 10 gig, so you will have total 480 gig, okay, and your top of it you will have, for example, 4 gigs of 40 gig. So this is 160 gig, okay. So your oversubscription is here. You can see 3 is to 1, okay, on the egress side. But on the egress side, you don't have it. Okay. But anyways, this is only one thing, just one point of view. But again, if we talk about VXLAN, we are having some problems in our layer 2 environment in the data center. Okay. So some people like told, for example, let me draw it with the distribution layer only. So I'm not drawing core layer. So let's assume your SVI is on the distribution. That means everything below distribution is layer 2. So you will have access switch 1, access switch 2. Okay. And this is complete layer 2 environment. So what is going to happen here is some of the links is going to be blocked, right? Because of your STP, which is spanning tree. So let's assume like this link is blocked, okay? Or this link also blocked, okay? So so these links you are providing it for the redundancy, right? You brought it, but again, due to STP, they are blocked because again, if they are not gonna block by STP, then this is gonna be a loop, okay, which can happen. So STP is gonna block it to avoid loops, okay? So this is one issue, okay? Second issue is how many VLANs you are having in total. If you are dealing with L2, how many VLANs you are having?
4096.
Okay, so VLAN is a 12-bit number. So 12-bit means 2 to the power 20 to the power 12, which comes around to 4096. Okay, so this is the limitation of VLANs. So if you are a service provider company, if you want to provide multi-tenancy, means you are having multiple customers and you need to segregate their traffic. Okay, so this is gonna be a very less number for them. Okay, which is already exhausted. So before VXLAN, there are other techniques they are using like Q in Q and all that stuff to avoid this limitation. Okay, so that is again one of the problem. Okay, and why we need L2? What is if this is my distribution switches? Okay, and for example, this is my core, this is my axis. Why I need to draw? Why I need to have L2? Okay, I can make it complete L3. So what is the issue in that? Tell me, guys. Why actually we need a L2 in our environment? We can go with L3 till our access layer. What is the problem in that? So one issue is someone
Limitation
like,
of IP addresses.
yeah, so ITP addresses is gonna used more, okay, which is gonna be a limitation for your IP address. That is one reason. What is another reason?
Port count.
Need to create more subnets.
So sub need to create more subnet means you need to have more IPs, right? So that is there. What else?
You cannot handle number of ports.
So port is again the same. If you are connecting a host, either you're connecting over layer 2 or layer 3, you are having same port count. Doesn't matter for port count. What else?
Maybe there would be a delay because there will be continuous routing table updates needed.
That is actually not true. Even your convergence of L3, I think, is going to be fast
Okay.
than L2. L2 is having more time as like if, for example, if your STP root switch goes down, what is going to happen? It's going to take more time, right? Or if a TCN is received, MAC addresses is going to be flushed from all the devices. So, okay, let me tell you guys. So VM mobility, do you anyone heard about this term? Or V motion? So VM mobility means if you want to, so again, guys, I hope you knows what is VM, right? Virtual machine, which runs in your hypervisors. So VM are the virtual machines, which is gonna be move between one hypervisor to another based on the different parameters, okay, like your CPU usage or RAM usage or whatever it is. Okay, so for example, if any hypervisor is using less resources and one is overloaded, so it automatically moves your VM from one to another. So for VM mobility, you need to have a common layer 2 domain needed. Okay, because again, when it moves from one place to another, its IP is not going to be changed. Okay, subnets is not going to be changed. Okay, then there are some clusters, database clusters, which needs L2 domain again. Okay. If you want to do any live migration, okay, over your L2, then also you need a complete L2 domain end to end. Okay. So these are some of the reasons where we need the L2 domain end to end. Okay. So to overcome these situations, you will have the need of a complete L2 domain is needed. Okay. So for that, different solutions come. Okay. And after that, the widely accepted solution is VXLAN. So how it gonna solves your issues, okay, or how it gonna cater your needs. So VXLAN, if we talk about topology, it can work over 3-tier as well, okay, but generally suited for 2-tier design. Again, 2-tier design is also needed for your east to west traffic flow, which is server to server traffic flow, okay, which is nowadays 80% of the traffic flow, okay, in the data centers. So if this is a particular host which is gonna be there into a particular VLAN, for example, VLAN number 15, and then also this is gonna be a particular VLAN 15. So if we are running L2 from our L1 and L2 links between our spines and leaves, okay. So this is gonna be a 2-tier fabric, okay, or 2-tier architecture where you will have 2 tiers, okay. So this is your spine layer, which consists of some switches. Okay, so if we talk about data centers, this is going to be a Nexus 7K, Nexus 9K, like that. And on the leaf layer, you will have Nexus 5K, Nexus 9K. Okay, so these models. Okay, so leaf and spine. Now, what is going to happen here is if you are having spine between spine and leaves, if this is L2, then everything is good. Okay, but if these links are L2, then you know what is the problem we are having. We are having a problem of STP, right? We are also having a problem of large broadcast domain, because if everything is in the one broadcast domain, if you do any broadcast, it's gonna goes to all the devices in that broadcast, right? So that is also issue. So what they made is into VXLAN, they make these links are L3. So if these links is gonna be L3, then we are having some other issues exist. Okay, so what are those issues? So for example, if this is your one path or one domain, which is like this, and okay, this is L2 till here and here. So now what is gonna happening here is you will have a L2 domain, okay, from your host to the device. Then you are having a L3 from device to device, and then you are having again L2 to your host. Okay, this is what again I have made the same picture with a different view. So now this is the problem is your L2 domains is gonna be separated via L3 domain. Okay. So they are not part of now same L2 domain. So how to make them a part of same L2 domain is now the question. Okay. So how to make it as a part of same domain is now we need to make one tunnel over my existing L3 infrastructure, which is gonna pass my L2 traffic in this. Okay. So both side, vice versa as well. So your arrows can be like this. So now logically, if you see, this is equivalent to now that for end host point of view, it will think like I am directly connected to other host over L2. Okay, this is the logical equivalent of your this one. Okay, so now this tunnel that we are creating in between over L3 infrastructure is known as VXLAN tunnel. So what VXLAN is do, it's gonna make the tunnel between your two leaves, okay, between your two pair of switches, so that your L2 can be combined together so that they will think that they are on the same subnet. Okay, they can talk over L2. They don't no need of L3 to talk to each other. Okay, so that you can do your live migration or you can do vMotion and all the clustering and all that stuff. Okay, so this is now. So due to this, now all links we can make it as L3. Now you guys can ask like, how we gonna solve the wastage of our IP addresses? So yes, we can solve that as well. Okay, there is a concept of IP unnumbered. Okay, so those who knows that concept, they know with help of this we can solve IP wastage. Okay, but those who don't know, do not worry. I'm gonna explain it more detail when we start with the course. Okay. Okay, guys. So this is what it gonna solve so that your L2 domains can be connected to each other. Okay. If they are part of different data centers, so your data center replication can also be done over L3 because again, over any L2 domains you can connect. Okay, over part of it. Now, how it gonna solve your problem of 4096 VLANs, because this is also one of more problem for us. So to solve this problem, your VXLAN, so VLAN is gonna use 12 bits only, which will gives you 4096 VLANs. Okay. VXLAN is gonna give you 24 bits. So if you talk of, if you see 24 bits, that means 2 to the power 24, which comes to approx 16 million. Okay, so 16 million segments now you can form. Okay, although this is a theoretical limit. Okay, no one reaches to that limit. But again, now service providers can provide multi-tenancy. Okay, they are having a lot of ranges to provide to different customers. So means your 16 millions L2 segments can be connected together over VXLAN tunnel. Okay. So this tunnel, if there is a tunnel, then there is going to be an encapsulation and decapsulation, which is going to happen. So again, that is what how it's going to happen that we're going to discuss in the course itself. But this is a high level concept of VXLAN, why we use it. Okay, what are some of its advantages? What is the design over which we can use it? Where you gonna use it? Okay, what are the basic things it needs, like that. Then there are other advanced things as we're gonna move on into our course, we're gonna discuss about that. So guys, tell me if you have any doubt, any question related to the VXLAN topic. Okay, like this introduction, whatever the question you are having, you can ask any question. Okay.
Not related to VXLAN, but is ACI and DNS center are the same or different?
Sorry, ACI
And DNS center are both the same?
Okay, so I am parking your question. I gonna just tell you in next 5 minutes. Okay, so right now, whatever the questions related to VXLAN, Any doubt, any basic question, any doubt you are having, guys, you can ask anything. Make a good use of this session. If you are joining this session only for the knowledge as well, you can ask me anything you want related to this.
Sorry, sir. Can I ask?
Yes, yes, please.
The meaning of spin on the VXLAN is like control plane or data plane, similar or not?
Where?
The meaning of spin on the VXLAN is like control plane or data plane, like concept of the SDN Cisco DNA, like that.
So if you are using VXLAN directly without SDN, your control plane and data plane is directly on that device. If you are using it into the SDN, that it can now differ based on your SDN controller and all that stuff.
Okay.
VXLAN you can run without SDN solution as well, right? Directly on our Nexus devices, it supports. And VXLAN, by the way, is a industry standard protocol.
Okay, sir. Thank you.
Yeah. Okay. What else? Any other question, guys? It seems like you guys, I hope, joining for the VXLAN class only, right? Okay.
Hi, I have a question. The question is, can we use this VXLAN concept if we have two routers, like two different sites, and using VXLAN to extend our layer 2?
Yes, you can do it with a intra-DC, you can do it. No issues. So again, what are the solutions you are having if you are having a multiple data centers? How you normally connect your data centers to each other?
MPLS.
And what technology you run? Sorry?
MPLS.
Okay. What else?
SD-WAN.
What else?
KRE tunnel.
What else?
Site-to-site VPNs.
Site-to-site connection.
Okay.
And also
Then,
a simple VPNs.
Okay. Anyone heard about OTV?
No.
So OTV is a data center solution, like to do over Nexus. If you are having, you can configure with OTV as well. So again, like that way, VXLAN can also be used to connect your data centers. And before VXLAN, there are other protocols as well, which are used to do the same thing, but they are not like VXLAN wins over it, because again, it has one unique thing which is missing in others. So like, what can anyone tell me what is the previous protocol, anyone using it before VXLAN, if anyone knows? Do anyone knows about fabric path? Okay, then leave the discussion, because again, if you don't know about fabric path, it's, how can I tell you that how it is advantage it over fabric path? Anyways, fabric path is Cisco proprietary, and it is again a tunneling type of solution. But again, fabric path is uh, like it is L2 over L2, okay, not L2 over L3.
Kind of like a L2 VPN that we use earlier to extend our
Yes, yes,
like a layer 2 connection between two data center over MPLS, right?
right, right, right.
It's
So again, the
it's like a
concept,
EVPN, right? That we call
yes,
something.
yes. So again, the concept is again the tunnel, okay? The concept is again the overlay. But here, some things are much better than other protocols like BGP VPN family is used to learn your other side addresses, or basically I can say MAC addresses through control plane. Okay. So guys, if let me, although right now I not want to discuss that thing, but it's okay. MAC address learning. How MAC address learning is gonna happen in traditional network? Just a simple question. I hope everyone knows this thing.
ARP.
Okay, but for example, okay, this is a switch. Okay, this is my host which is connected to this switch. Again, I have another host which is connected to this switch. Now, host one wants to send the data to host two. Okay, so how the switch is gonna learn the MAC address?
Through the broadcast.
Okay, so there means some packet goes through from H1, right, to the switch, right?
Yes.
Yes.
And then switch learns it. So that means your packet is going into the data plane, right? What is the difference between data plane and control plane, guys?
Data plane
Just
is a
quick.
forwarding plane. It just forwards the data.
And what is control plane?
The control plane is area which makes most of the decisions like where to, what to forward and where to forward.
Okay, so basically it's gonna build your tables, right? For forwarding. Builds table for forwarding of data, and in the data plane, your actual data flows, right? Which used these forwarding, which is built by control plane. That is the reason like routing protocol we use. Why we use routing protocols?
To learn the route.
Okay, so to learn the route, for example, if this is connected to a router and then I am having host, how to connect to this, how to get to this host. Okay, there are some subnets, for example, in between. This is 10 subnet, this is 11 subnet. So you're gonna learn that route. Okay, so to learn the path information, right? That is the role of control plane, and then your actual data plane is gonna go through that. Okay, so what is gonna happen is your MAC address learning is gonna happen through the data plane. Okay, so there is no control plane who is gonna build your MAC address table. You getting my point? So to learn the MAC address from a host, or to learn a MAC address from one switch to another switch, there is no protocol, control plane protocol. Or do we have any control plane protocol to learn MAC address?
Not so control, but we have the MAC table, MAC address table.
So yes, MAC address table is gonna hold your MAC addresses, right?
Now,
But
whenever the host is trying to connect to some other host, first it will learn the host one MAC address, it will store and we will check the destination MAC address. Based on the port mapping or MAC address learning, it will store.
yes, so that is what I am asking. Your switch is not having the entry pre-built, right? With some protocol.
EVPN can help, right?
Yes, so again, I am coming to that point. But traditionally, you don't have it, right? Your MAC address, your MAC address is learning when the packet is coming from your host to the switch, right? Then only switch able to learn it.
Yeah.
Right? But there is no protocol like to learn the MAC address beforehand, right? Normally we use the protocol to learn the IPs, right? To provide the routes and to make the routing table and all that stuff. So your MAC address is basically happens in the data plane. Okay. But Due to this, the problem is this mechanism uses flood and learn. Now, what is flood and learn means? You need to flood the traffic and then you need to learn the MAC address things. Okay, like your ARP. What is going to happen when you do the ARP? Okay, what is going to happen when you do the ARP? You have a broadcast request. It goes to the switch. It's going to do the broadcast to all. Then host, which is having that MAC address, is going to reply. So when the reply comes, switch learns the address. Okay, so this is known as flood and learn. So this is an unnecessary wastage of the links, okay, which is gonna happening due to this. Okay, so to avoid these things into the data center, this is what VXLAN uses one protocol which is known as BGP EVPN. Okay, this is protocol which is gonna use control plane to learn your MAC addresses and IP addresses, both. So for example, if this is your one leaf, this is your another leaf, this is your another leaf, okay, all are connected to the spine. This is a very simple topology I'm making. Then there is a host which is connected here. There is a host which is connected here. There is a host which is connected here, okay. This host is having a MAC address of, for example, A, an IP address of 1, MAC address of B, IP address of 2, MAC address of C, IP address of 3. Okay. So now, if my leaf 1 knows MAC address and IP address of this into a table, okay, and then MAC and IP of B and MAC and IP of C, before sending any data, if leaf knows about it, then do you think we need a ARP?
No.
Right? So unnecessary broadcast, we don't need to have it. Okay, that is known as ARP suppression that we can do in the VXLAN. So BGP EVPN is a control plane protocol. Again, guys, this is not a data plane. This is a control plane protocol, which is gonna helps you to learn the MAC address and IP addresses, okay, into your VXLAN. So this is very important. So this is gonna reduce lot of traffic in the data center. Okay. So again, this is just a very basic understanding. We're gonna go deep dive into the course. Okay, when we do it. So again, every leaf is gonna know about all the endpoints or all the hosts which are connected to other leaves before even sending the packet. Okay, so that unnecessary app will be reduced or unnecessary broadcast is gonna be reduced. Okay, so this is the advantage. This is one more advantage of using VXLAN. Okay, which is why it is very popular. Okay, guys, so that's all related to the theory part of today. So you guys now having any question you can ask. And also I want everyone to open it chat link. Okay, in the chat link there is a chat given by Network Journey official account. Okay, where you will have 2 WhatsApp numbers and email IDs. So related to the course fees, you can directly contact on these numbers. Okay, and then you will have the complete details available to you. Okay. Apart from that, if you have any doubt, any question, you can ask me. Yes. Any question, guys? Any doubt? Any question? All
Sorry, sir,
good?
I don't understand of the BGP VPN.
Okay, so this is
The
again just an introduction. If you're not able to understand, that's okay. We're gonna have a complete class over it.
Okay. The meaning of function of control plane for BGP VPN is like what, sir? I don't understand, sorry.
To learn the MAC address and IP addresses of your hosts from a control plane point of view. So they don't need to send the data packet like ARP to learn the MAC addresses of other host. Okay, anyone having any other doubt, question? Okay. So guys, tomorrow again on the same time, which
Yes,
is 8 p.m. IST. Yes, Amar.
yes, sir. I have a question. How about if, for example, host one moves from location one to location two? Like, so how often the tables gets updated and maybe there's
Again,
a conflict?
as soon as it moves, it's gonna
Yes.
generate a BGP update, and it's gonna
Right.
be automatically updated to all other leaves.
Right.
Yeah.
So it's
So it's gonna
like every leaf would share its MAC address table with its neighboring leaves, right?
Yes. So what it so it's not like the complete MAC address table. It's gonna be based on your MAC and IP both. Okay, it depends. Like there are different type of sharing, which is gonna happen. Either they only can do MAC, or they're gonna do MAC IP, or they're gonna only do IP. All those things will be discussed.
Right. Right.
Yeah. Okay, guys. Yeah. Yeah, Vijay.
I'm asking you, every host which is connected in leaf, every leaf is content every MAC address IP which is connected the host maintain the table.
So again, it depends. If there is a silent host, then and it is not sending any packet like DSCP or any type of packet, then leaf will not have the entry.
If I leave have I leave have the 100 of servers which is connected in leaf server to every server MAC address and IP address should maintain the table in leaf and as well as a spine both.
So again, whether it's gonna be in the spine, that is a different point of question. So we're gonna discuss that later on. But yes, if that host is ever communicated or it is sending any packet to your leaf on boot up, then it will get the MAC address table, MAC address of that.
MAC address and as well as IP address, right?
So IP depends. It depends on the other factors, which we're gonna discuss.
Okay, okay. Thank you, sir.
Yeah. Okay, guys. So tomorrow again we are having the same class where.
Yes. Sorry. Can I ask just one last question?
Yes, Aman.
So it seems like that everything connects to one center point, spine. What if
So
the
again
spine
here,
fails? Yeah.
there is going to be a redundancy. I only just made one spine only for simplification of topology. Okay, you can have multiple spine.
Right, and we are assuming that these connections are actually, they can be remote, like in two different data centers.
So remote leaf, you can do it in the ACI. Okay, there is a different concept for that.
Right.
Yes, so you can do that.
Right. Thank you.
Okay. Okay, guys. So tomorrow again we're gonna have a same session where we're gonna do discussion on ACI and SD-WAN. Okay, so VXLAN we done it today, the basic part, and ACI and SD-WAN we're gonna do it tomorrow. Guys, again take a link in the chat because all other details related to the course fee and all that stuff is gonna be. You can talk on these two numbers, okay, and you get all the details. For next 3 days, there is a discount offer that is also running on. So those who gonna join, we're gonna have a discount. After that, that is gonna be closed. Also, I'm gonna take a very limited number of students in the class, so I not teach 20 students or 30 students. Okay, so those over who are early joiners can only be enrolled. Okay. So, okay, guys. So thanks a lot for joining today. Tomorrow again at the same time, 8 p.m. IST, we're gonna meet and discuss
Yes. Okay. Thank you, sir.
related to it.
Okay. Thank you.
Okay. Thank you, everyone. Have a great day.
Thank you.